Hello. First, to introduce our company, Safetics is a robot safety intelligence development company, and is distributing software named SafetyDesigner. SafetyDesigner is the optimization tool for cobots that provides collision safety analysis, which is an essential requirement when using cobots without installing safety fences or sensors. To use cobots safely, there are generally two methods. The first method, collision prevention, requires installing safety fences or safety sensors. However, this has the drawback of requiring a large space and the robot stopping when a person approaches closely. The second method is the collision allowance approach. If it's proven to be safe even in the event of a collision, it means there's no need for additional sensors or fences because there are no inherent risks. This is referred to as power and force limit (PFL) operations, as outlined in ISO 10-18-2. With SafetyDesigner, not only can collision safety based on safety standards be analyzed, but it also recommends the optimal speed. After the safety analysis, a safety report is automatically generated and you can print it. Now, we start how to use SafetyDesigner. SafetyDesigner is web-based software, which means you can access it through any computer. So, once you log in, you will be able to see the sample application that we basically provide. Before I show you the steps to run a new analysis, I will show you a sample application to give you the idea. The sample application looks like this. This is a machine tending application with universal robots. As you can see, you are able to add 3D objects of cell equipment and design a 3D cell layout prior to installation. Then returning to the main page, I am going to explain step by step. First, create a new project. If it is prior to installation, choose Pre-Start. If installation is taking place, then choose In Process. If the installation is finished, choose Completed. Choose the project schedule from the calendar. If it has not been determined, then click To be determined. You can also leave a note for your reference like this, but it is not a required field. Then you will see a new project created on the list. Enter the project, and create a new application. Type in application name, and select the application type. If the application you are trying to apply is not on the list, then directly input the information. We will choose Pick and Place for the demo. You can also leave a note here for your reference. After creating a new project and application, first upload a 2D layout. We are providing the function to upload layout in 2D image format. Prior to installation at planning stage, users might not have a CAD drawing. In this case, users can simply draw the layout on PowerPoint as an image file and upload it to run collision risk analysis. After uploading the layout file, set the ratio so that the two orange dots to the actual known distance within the diagram. Then type in the distance on the bottom left corner. Lastly, set the grid center position. Move the orange dot to the center of the diagram to set the global coordinate. Uploading 2D layout is only an option. You can still build the layout and run analysis only with 3D objects without any 2D layout. However, if you have a 2D layout, it could be easier for you to design 3D environment. In the Equipment tab, you can choose equipment from the list. We are planning to add many more libraries so that you can easily design a cobot cell using just drag and drop. I will show you uploading a 3D equipment as an example. Here, I will upload a conveyor belt. You can move it around and adjust its size like this. You can move it around with the controller or change its coordinates from the right bar. By the ways, even without 3D objects you can still run collision risk analysis only. Now add a robot from the library. You can choose the robots from the following manufacturers from the list. If the robot you are trying to add is not on the list, then as long as we receive simple information of robot geometry and mass, then we can easily update the list. For robot installation, you can add the robot base stand first. I will choose UR10 for the demonstration. Type in robot name, type in the robot serial number. By the ways, I am typing in a random number as this is a demo, but in the actual application, you would have to type in the correct serial number as it goes on the collision risk analysis report. So if you are trying to utilize the report as a safety documentation, then you would obviously need to type in the correct product serial number. Lastly, type in the robot installation location. Then you will be able to place the robot on the location that you would like. As you see here, you can create motion using the Move J and Move L function, as these are the most frequently used for robot movement. Right-click on the robot and click Hand Guiding, and you can move the arm around and set waypoints like this. This could be a handy function for you to run collision analysis on the planning stage if you don't have an actual robot installed to program the motion data. I have set 3 different waypoints. You can check if the motion you just created is appropriate. You can either use generated motion from SafetyDesigner or actual motion data extracted from the actual robot for the accurate analysis. To print out collision risk analysis report, you would need to analyze with actual extracted motion data for most accurate results. Let's delete the motions that we created just before and then upload the actual extracted motion file that is in TXT file format. For the extraction, we are providing a motion extractor program that you can download from the Guide Center. You simply need to connect the PC to the robot and use this program to easily extract motion data from the robot. Next to the end effector, you can either choose a default gripper model of OnRobot from the following list or upload a customized gripper. I will upload a customized grip for instance. To upload your 3D CAD model for the gripper, they simply need to convert it into STL file and upload it on the SafetyDesigner. I will demonstrate with a custom gripper that I just uploaded. Once uploaded, it will show the gripper like this. Now, since the program also does not know which part of the gripper could be risky upon collision, so where on the gripper that collision could occur. For this reason, you need to manually set the possible collision points on the gripper. On Collision Point tab, you will see a sidebar menu for creating collision point shapes. Enable Create on Gripper, and once you place your mouse over the gripper, you can see a shape floating. Create a shape on the point that you consider that there could be collisions. Then disable the function, so that you don't see the shape. Then adjust the shape's radius, fill LED information and its position and direction to align the shape to the points. Lastly, setting the area where workers will be positioned, and specifically where possible collisions are estimated, can be set on Collaborative Workspace tab. You simply draw the area in rectangular shape. Since workers cannot work in a fixed position, and slightly move around, it is important to set the area in a range like this. Then you need to choose expected collision body part that could collide with the robot. There is no specific standard for choosing the body part, since even with same application, depending on the height of the workers, collision body parts can differ. For instance, a tall person could collide with their chest while a shorter person could collide on their head. So, this has to be judged intuitively by users through environmental assessment. Now all the settings are done, and we are good to go and run the analysis. Before that, analysis options need to be set. As simulation cannot be run consecutively, it needs to be cut into time unit. Smaller the time, more accurate the analysis data, longer the time, quicker the analysis will be completed. Choose the safety reference standards, either one or both. We provide 2 standards. One is the pain tolerance, and the other is the pain onset threshold. All settings are now finished. Let's run the analysis. Once the analysis is complete, you will be able to see a pop-up message like this, and next to the 3D Workspace tab, you can see the results page. You can review the results based on the safety reference standard you have selected on the analysis option. As we have selected both, you can review with both standards. If playing the motion, you can review the speed, CRI values and recommended speed according to the real-time motion. CRI value stands for Collision Risk Index. Recommended speed is provided if there are any CRI values that exceed the safety line. Since this one has no exceeding points, I will show another result that has exceeding points. As you see, for the exceeding points, recommended speed is provided in percentage. As only the exceeding points need to be reduced, overall average recommended speed is not reduced by much, so productivity can also be secured. You can also review the risk space video, which shows you the collision risks involved with entire moving trajectory of the robot, even in the area that no collisions are expected. With this result, users can optimize cell layout by changing worker position to secure both safety and productivity. Finally, you can print collision risk analysis report that will show you detailed analysis report of the results. I will show you a sample report to give you an idea of what it looks like. You can also share application that you have designed with others online through Share Application function. Using this, share it with related person through email such as your client. Enhance both the productivity and safety of your cobot. Thank you for watching the SafetyDesigner demo.